Okay, go to page 6 of your notes. We took information on the sliding filament model or sliding filament theory. That's where the myosin digs in to the actin and pulls it closer together. The H zones disappear. We need to talk about how ATP is obtained. So let's talk about this. Remember, calcium will keep pulling on the troponin, which pulls the tropomyosin off the binding sites as long as there's energy available. ATP pumps the calcium ions out of the sarcolemma, which surrounds this myofilament. Thus, that's how you relax. Remember, without ATP, you don't get relaxation. No energy, no relax. Thus, you get rigor mortis, stiff death. So let's talk about this, how ATP is obtained. So this goes right along with your notes, and I don't want to talk about it. This will continue as long as ATP is available. One of the sources is creatine phosphate, because remember, ATP is adenosine triphosphate. So creatine phosphate actually is extra phosphates. When ATP is broken down, it's a phosphate plus ADP. So we can creatine phosphate contains high energy phosphate bonds and is a storage depot for energy in a cell. Okay, I know you can read, but when ATP is depleted, creatine phosphate breaks down and releases its energy to regenerate the ATP. That sounds great, but we'll talk about this when I'm all done with this. So here's what we usually think of as creatine. You make this on your own. This is additional phosphates. It's not energy, it's possibility of energy. When muscles are particularly active, ATP and creatine phosphate sources may be exhausted. So what happens is creatine doesn't make you stronger, it gives you more energy. If you have more energy, you can work out longer. If you work out longer, you work out stronger. If you work out stronger, you're going to build muscle. So it's not necessarily that you build muscle taking creatine, but it just gives you more energy. So if you no longer have ATP and you no longer have creatine, you are relying on anaerobic respiration. That's not very efficient. If anaerobic means without oxygen. So that means when you have depleted oxygen, pyruvic acid is converted to lactic acid. That goes on your blank, I believe, in your notes. And 2 molecules of ATP are produced. That's not very much because in normal aerobic respiration, when you've got lots of oxygen, you're making 34 to 38 ATPs. That's a whole different story. You're getting way more energy. This isn't very efficient. Basically, you're fermenting your muscles. You're making them acidic. When you make a muscle acidic, it starts to hurt. So lactic acid. As lactic acid accumulates, fatigue sets in and oxygen debt develops. Oxygen must be supplied to relieve this buildup. That's when you start getting pain. You get the cramp. You get that kind of thing. Lactic acid changes the pH of a muscle fiber and can no longer respond to stimulation. It's carried back to your liver where it's converted back into, that should actually say glycogen, because glycogen is the glucose that is stored in your liver. Glucose works on a test, but glycogen would be better. So I need you to look at these 3 pieces of meat. Which one do you think has the ability to carry more oxygen? You're like, meat carries oxygen? Well, it's got something called myoglobin. Kind of like hemoglobin is in your blood, myoglobin is in your muscles. And if you look at it, this is really white. This is not great, but it's chicken breast, so that we call that white meat. And this is a steak, and that's really red. But myoglobin, this is very important, and I asked 2 questions on this on your test. White muscle, that of a chicken breast, contains very little myoglobin. Thus, it has little oxygen. Little oxygen is stored and ATP is used very quickly and lactic acid builds up. What do you know about chickens? Chickens don't fly because if you look at it, they don't have much myoglobin in the chicken breast. They can't store a lot of oxygen. They're going to use the energy very quickly. So they can go up, fly, and then they kind of fall. Now, what do chickens do a lot all day? They walk around. So that's why their legs are called dark meat. Okay, so this white muscle is fast twitch muscle. Red muscle, like that in the chicken legs, has a large amount of myoglobin, it stores a lot of oxygen, and can generate ATP. We call this slow twitch muscle. So that's kind of cool. So I want you to look this up, but let's go back again. Now I need you to think, where does a duck have white meat? That would mean what muscle does a duck not use very often? So a lot of people like flying, so they're breast meat. Well, ducks fly south for the winter. Oh yeah. What about legs? Well, they swim all day. Oh, darn it. Ducks don't have white meat. That's why when you're eating duck or anything like that, it's going to be all dark meat. And I'm not sure what this is from. I bet it's from fish. And fish do have dark meat, and we can talk about that in class. It's kind of hard to explain. But I want you to look up Long distance runners, do they have more fast twitch or slow twitch fibers? Sprinters would have more of which? So I need you to think about that based on the color of the muscle. Think about where humans have white meat. So if I was going to cook you up, where would the white meat be? Don't get grossed out. I'd have to cook you really well. So that concludes our notes on that.